Hello everybody and welcome to Gregg's Vintage Workshop, where I'm working to destroy history one piece at a time. Tonight we'll be looking at part 3 of the Philco 42340 radio, and in part 3 I wind up having to rewire this entire radio. The rubber wiring was just really too bad, and so we'll get that done. I replaced the caps, I replaced a lot of the resistors, I test basically all the coils, and then I will be testing the tubes. We'll see how that works out. So without further ado, let's get started. Okay, so this is that third IF can. I took it apart, took it out, took it apart, and I wound up having to put a new resistor in it here. That was supposed to be a 47K, 47,000 ohm, and it tested out 71,000. So I changed that out, and then I did not want to disturb my little coil wires, so I basically extended all of them into cloth covered wire or silicone wire. My black and my red wires are silicone coated wires, and then the other three are cloth covered wires. So let's go ahead and test this now. I'm going to set it down, and then I'm going to get you zoomed in on where you can see the meter as well. Okay, so that's the MFP. Let's see if I can get this where you guys can see it. So according to the schematic, the white to the red should be 13 ohms. So let's do white to red. How much of this you're seeing here. Okay, we're going to do white to red. And we got 19.5 ohms, so it's higher than the 13, but at least it's not open. Alright, so then we got to do green to blue, which the one side of the blue goes to the one side of the resistor, but we'll still see our continuity between there. So we're at 46.2, it's a 47K resistor I put in there, so that looks good. Now let's move this lead down to the other side of the resistor. And we're at 19.7. So I think we're good. I get the lead back out without breaking a wire. Those wires are so fine, they're like little hairs. Like little human hairs. But anyway, that's it. I got to get back in the can now. Alright, I got them in there. It wasn't the easiest thing to do, but I got it in there. I had to pull it out once. I didn't have it lined up the way I took it out, so I want to make sure I had it right. So I pulled it back out, turned it around. I was 180 off on it with the wires from the photos that I took. So it's ready to go back in. I'll do that and we'll come back. Okay guys, I'm manipulating my camera around to try and get you guys better shots. I wasn't real happy with what I had on part 2 from directly above my head. So I've got a different angle coming on tonight, so hopefully you'll be able to see a little bit better. I need to blow this out a little bit, but what you can probably see right here right now is this is that power resistor I was telling you about. It's a 740 ohm 20 watt power resistor, and I got it screwed down using that one Philco hole. So that's in place. I got the volume pot out and I've cleaned it up and shot some lubricant inside, Now, according to the print, I can't make this out. And you guys, because you're on the opposite side, you're going to be backwards. So I got to turn around like this for you to see it. I'm pretty sure that says 0.5 meg. It could be a 3, but I think it's a 5. So I think it's a half meg. I think it's a half meg pot. And so I got it off and I got the terminals all cleaned up. And we'll hook up to this meter here. And I'll turn it around so hopefully you guys can see it. And we'll check it. So let's power on here. And we'll get it to ohms. And I can't see it, to be honest with you, because I'm backwards and because of this is the white display. But anyway, let's go ahead and try and get it, hopefully you guys can see it. So we'll get this hooked up to the two outside on there. And it's coming up, if I can see this properly, it looks like it's 598, maybe 580. Let's see, 598 I'd say. So slightly over half meg, about 600,000. So that's why I'm thinking it's I think it's a half a meg, and we're at 600,000. So I'm fine with that. I think that's plenty close enough. So now we'll move it over to the center and put it through its paces. Now realize this would typically be done on a analog meter versus a digital meter, but it actually is not bad. I mean, it's not. I've seen better, but I've certainly seen much worse. I'm going to turn this as slowly as I can, doing it backwards. So hopefully you guys can see it actually is doing a pretty good job. Had a little out of range here for one little split second. We're up to K ohms at this point. I can see that enough. I'll keep spinning it and keep going. And I think it's going to do pretty good. I don't think there's anything wrong with it. Let's put it like that. I've seen much worse. Of course, I've seen much better. So all in all, I think we're okay, and that's where it ends up at, about 596. So I think the pot's going to be fine. I'm going to put it in, and we'll go from there. So as I was saying, I do have the third IF back in. I've got all the wiring hooked up for it. I don't have a pointer. I guess I use these tweezers. I don't know where my pointer is under. I got my bench is a very big mess right now. Any of you guys that do this probably realize, if you're anything like me, that your bench gets very messy. But anyway, so here's the white wire in here. If you guys can see that, here's the green wire. This is all cloth. Here's the blue one that goes over to the pot, and then the black and the red are right here, and everything's good to go. So I'm going to go ahead and get this pot put back in. I'm going to change this cap. This is the one that goes over the center, which is a, if I can read it here, looks like a 0.01. Let me take a look here. It is a, yep, 0.01. Right here, if you guys can see that. 0.01. So let me get that taken care of. I've checked this resistor and it checked fine. This resistor checked fine. This one was fine. This one's fine. This one's bad. This one's fine. I have to get this cap out of here. I got to get this resistor out. I very well may change this resistor just because it's right here and kind of in my way. I don't know. We'll see. But let me get this pot put back in here and wired back up. I hate these nuts. This is what came on it. I hate these. I had a heck of a time getting those screwed back onto that third IF can, and I wish it was just like a regular nut. It's not my radio, or I probably would have just changed it to a regular nut. And they're hard to start. That's the other thing. That's what was so hard about on the IF, was trying to get the doggone thing started. There we go. Got it started. The meter's shutting off. Alright. These wires hooked up. The blue one, that one, and a cap, and I bring it back. Okay guys, I've been working my little fanny off on this rubber wiring in here and replacing components as I've gone through. So, as you can see, pretty much all of the rubber wiring at this point in the radio is replaced, with the exception of some rubber wiring. If you're seeing this, I don't know that I'm over far enough. The rubber wiring on the second IF, I still have to pull the can off. It tests okay, and I can show you that here in a second. But it tests okay. I haven't checked the first IF yet, but all of the rubber wiring has been replaced up to this point. Everything is new cloth covered wiring. I've got the 12 microfarad electrolytic here replaced, which is shown here on the schematic. That's that one. And here's one of the 4s, which in the schematic it's a 4. What was in here was an 8. There was 2 8s actually, all in the one cap here. But somebody else had been in here and worked on this. It probably should have been 2 4s. I didn't look at the schematic at the time I ordered the parts, and I saw the 2 8s, so I ordered 10s. So I didn't have 8s, so I put 10s in. I'm sure it'll be alright. But that's what we see right here. They're stacked, one on top of the other, and they're solid, and they're all tied in. So I got this one. Well, you're probably not seeing it, I think you're off camera, but it's the 12 that I just showed you right here is now a 15, and the 2 4s are now 2 10s. I've been replacing resistors as I've checked them, and the ones that have been out of tolerance I've changed. Now this one here was not out of, I take that back, this one was out of tolerance. This was supposed to be a 1 meg, and it was testing like right at 3. And then these two were okay, but I changed them anyway because I had to do so much soldering in here. I didn't want to put too much heat in them, so I just went ahead and changed them out. This is the 220 ohm resistor right here, and it tests fine. The 68 ohm next to it, it tested fine too, but it's actually one of these right here. I think it's this one right here. And I decided, because I was putting so much heat to it, I was going to change it. So I changed that, and here's the power resistor that I had showed you earlier. It's taking the place of the field coil right here. Field coil is 1700 ohm. This is 1740. It measured 1730, and it's again 20 watts, which is overkill for the wattage that's on here. Probably only needed to have about 5 or 6 watts, so I should have used a 10 watt to have the overkill for it. But as you can see, it's very small and it fits in here perfect anyway, so I'm happy with that. So pot's all cleaned up, working well, installed. All of the condensers at this point have been changed. So where I'm at right now is I've got to get the second IF out and change to cloth covered wiring, and I got to get the first IF out, which you can't see right now. Let me, since you've seen this now, let me shift the camera over so we can look more on the other side of the radio, and I'll show you where we're at right there. So if you guys can still see this, so this is the second IF here that I was showing you earlier that I pull out and put cloth covered wiring. This is the first IF, and this one actually only has 2 of the 4 wires have rubber. 2 of them have either already been replaced with cloth or they were already cloth. My guess is they've been replaced previously. And so I just have to pull it out and do these 2 wires here. I've got a yellow wire right here that I've already run, that's cloth, that I got to hook up here. That goes on the same terminal right here next to it. I got to get that hooked up. I've done checked these resistors. This one's bad, it's going to have to get replaced. This one's good. The one down inside there is good. I got a black wire down inside there I've got to replace, and that'll be about it. And then I got, if you can see in here, I got this condenser here and this condenser here that are really buried, and it's buried underneath this antenna here, and I've got to get that out of the way. This is the shortwave antenna, and that's the oscillator coil. So I'm going to have to get the antenna coil up out of the way so that I can get in there, and that's going to really be tight. I got an orange wire that I still have to hook up here that came from way over here that I had to run underneath there. But I'm starting to get through this. I think that I'm on the last leg here. So I'll probably go ahead and pull the second and first IF coils and get those wires changed and hooked back up so I don't have to worry about them. And then I'll tackle this end piece. But I wanted to bring you back and see what I've been working on. Although this has been really quick for you, this has been really long for me. I've probably got about 6 hours just in this section right here, changing the parts, checking them, changing them, and making sure everything's right. So anyhow, I'll bring you back. Okay, so I just got through rewiring the second IF. I'm getting ready to test it. So I figured we'd come in here and test it. Let's flip on the MFP and get you zoomed in a little bit closer. Alright, so according to the schematic, the white to red should be 8 ohms and the blue to green should be 22 ohms. So let's see what we got. So white to red, you can see this. I'm going to hook up white to red. Put this on the ohm scale. So the white to red. It's like 8.4, 8.5 ohms, so that's good. That's right on the money. Let's go blue to green. It's at 22 ohms. We got 23.2, so that's pretty darn close. 23.2 versus 22, perfect. So that's good. I just got to get back in the can and get it put back in. So let me do that. Okay, I got it back in the can. Perfectly fine, so that's ready for me to put back in the chassis. Okay, so I got the first IF can here. I just got through fixing my 2 wires. The white and the green are both already cloth. I went ahead and took some marker and got the green one more green because you really couldn't tell it was supposed to be the green one, but when I tested it, while it was in the radio, I could tell it was the green and where it was connected at. So right now we're getting ready to test it since I did my work on it. So let's flip on the MFP and flip on that, and according to the schematic, on the white to red we should be about 1 ohm, and from the blue to the green it should be about 22 ohms. So let's see what we get. So let's see, white to green, no, white to red. White to red. We got 1.1, 1.2 ohms, so that's pretty close to perfect. And we'll go to the blue to green. Blue to green. We are 22.81, 22.7, and it says 22, so I think pretty good shape here. So go ahead and put this one back in the can and get it back in the radio. Okay guys, been a long time coming, but I finally got this radio completely rewired. There's no more rubber wiring in it. I got the first IF and second IF rewired. I got them back in, got those in, finished up this side of the radio. I tested this antenna coil. Nothing was open. It wasn't reading what the print shows exactly. And this one here is the same way. There wasn't nothing open on it, but it wasn't reading exactly to the print. But I'm at this point that I think I'm ready to flip it back over the opposite direction and clean up some stuff on that side and put some power to this thing and see if it's just going to do anything at all, or if I've totally screwed it up, or if it goes up in smoke, or what. Let me get this side button back up over here. I'm going to do some further double checking of everything compared to my schematic, and make sure I've got everything back together again right. So I'll do that. I also cleaned up the contacts on this switch and replaced any resistors that were reading out of tolerance. As you can see over here, this was tight, but I got them in there. Any old resistors, you can see those were within tolerance. So I only changed the ones that were bad. So we'll see what we get. So I decided before firing this thing up, or attempting to fire it up, I might as well check the tubes out. Probably should have already done it up to this point, but I didn't, so we're going to do it now. So this is my Dynajet model 606 tube tester, and I got the settings here. I'm going to work my way from the one end of the radio to the other. So we're going to look at the Xxl tubes first. So let me get this set up for Xxl. If we look at the Xxl, it is right here. So looking at the settings here, the heater is going to be 6, and then 41, and then 6, and 6, which that's the one for the shorts. And we're going to be using socket 4. Alright, so here's the tube. I cleaned these up. I was going to show you what I used to clean them up, but I think I've already discarded it. What I used, I never thought of it. There's so many things that I've seen that you can use it for, mainly get bugs off your hood of your car, but was a dryer sheet, like a bounce dryer sheet. It actually worked pretty good, and it didn't take my numbers off, so that's what I use. So I thought I'd throw that little piece of info out there. Apparently you can use it. I can see the filament glowing in it. You probably can't, but I can from this angle that I'm at, like this. We'll give it a second to heat up. Then we're going to go through the shorts. If this flashes, that's fine. It just can't stay on in any position. So like it just flashed right there. So no shorts. Go with the grid emission. It's fine. Let's check the quality. Oh, really good tube. That's almost 100. Alright, let's get the other Xxl. Alright, so it's already set up for Xxl, so here's the other one. Let's go ahead and get this plugged in. I can see the filament glowing in there. Alright, so let's hit the shorts. Looks good. Good emission. Good. Quality. Also a very good tube. That one's about 95. Alright. Now I'm going to check a 7B7. Okay, so let's go through shorts. No shorts. Good emission, looks good. quality. And it's in the good. It's not tremendously in the good. It's rising up a little bit more. Looks like it's about 78 maybe, but it is good. Let's get the other 7B7. And so it's going to already have the settings set properly for it. Let's plug it in. Check it for shorts. There's no flashes at all on this one. The other one had a flash between 6 and 7. This one's got nothing. It's grid emission. Not moving. Let's hit the quality. Nothing. This tube is dead as a hammer. Well, we got a bad tube. This tube is bad. Alright. Well, that's not good. Let's check the 7C6 next. Okay. There's a flash there to 7. I'll leave it on 3. Alright, grid emission. Not moving. Quality. Going up in the good. Almost 90. About 89.5. So that's good. That's a good tube. Alright, the next tube we're going to check is going to be the 7B5. Octal tube. They're all octal tubes. I can see the filament glowing down the bottom on that one. I couldn't see one on the other one. I think it's just the construction of the tube on that 7B5. Alright, so 7C6. Let's go through the shorts. A little flash there. Okay, grid emission. Green. Quality. Oh wow. That's almost to 110. That is 110. That's a great tube. Alright. Alright, so that leaves the last tube as being a 7Y4. So this is going to be the one half of the tube, and then we'll do the other half of the tube. We only have to change one setting. Okay, we're going to go for shorts. A little flash. There's a flash there. I get nervous when I don't see any flashes, but there was a couple in this one. Okay, so keep it on 3. Let's check grid. It's green. Quality. Good. 100 on 100 on that one. Okay, now for the second half of the tube, we're going to swap this over to 6. And hit quality. And that's even a little bit higher. For about 101, 102. Perfect. So, we have got one completely dead tube. One of the 7B7 tubes. So I'm going to have to get a 7B7 on order. I'll probably get 2 of them because that other one was kind of weak as well. And I'll get those on order from Bob DeBush's. There's no sense even trying to power this up knowing I have a completely bad tube. So I think that's what we're going to do. I was going to show you guys though my pile of crap that was left over from doing the rewire. So let me get the camera moved over there and I'll show that to you. So here's the casualty list from the rewire and part replacement on this 42 340. Can't even get it all out of there. I think that's most of it. See the resistors, all the wiring, all that rotten rubber wiring, all the caps, All the joints. What a mess, huh? Yeah, I'm talking mess here. That was a lot of crap. Anyway, I thought I'd show you that. Now, the other thing I'm going to show you before I end this video is the cabinet. The cabinet, all I did was wipe it off with Murphy's wood oil soap, I think it's called, Murphy's. I'll show you the bottle. Anyway, let me go in the other room and I'll show you. So we're getting ready to take a sneak look at the cabinet. I was going to show you what I used. My bottle is almost completely empty. It wasn't because I used it on this. In fact, I barely had enough to even spray this. I use this on all my antique furniture, and so I got to get me a new bottle. But that's what it is. The Murphy pure vegetable oil. It's a spray. It works pretty good. Works actually really good. And you don't necessarily have to put anything on after that. And I don't know if I'm going to put anything else on this except maybe furniture polish. So let me show you how it turned out. So that's what it looks like. Let me zoom in a little bit closer. And as you can see, hopefully you can see, this thing turned out pretty good. So I'm real pleased with that. I think he's going to be real pleased with that. That's just simply with the Murphy's oil soap. Now if I cock you down a little bit, there is just a little bit of damage right here where I can see the wood underneath. So I'm probably going to take some sort of a dark marker and try and touch that up a little bit. But for the rest of it, it's nice. Now what I've done so far on the inside was I sprayed the back side of this dial with clear coat enamel, because of all the flaking that was going on. I can get a dial glass for it, but the dial glass is like $33 plus shipping, so you're talking $40. And I haven't talked to my wife's nephew to see if he's going to be worried about it. I want to make sure the radio works first. I'll have it all together, and then I'll let him make the decision if he wants to pony up for a new dial glass for it, because I'm not going to buy him a dial glass for it. If he wants to, he can do that. But anyway, it's looking really good. I'm hopeful that my restoration of the radio itself is going to bear fruit. If not, I think I can probably figure out what's going on with it, but I'm hoping that maybe once I get a tube and I power it up, things are right and it actually starts to work, and all I will have to do is do the settings on it. So anyhow, that's where we're at. I think I'm going to end this part 3 of the Philco 42340 right here. And in part 4, I'll have my new 7B7 tubes from Bob DeBush, and we'll put them in, and I will hook this thing up to the new MFP. We'll apply power and check some voltages and see if it comes to life. If so, then I can use the other portions of my MFP and use the frequency counter and hopefully my dummy load and all of that. So I'm hopeful to try all my stuff out on that. But for now, I think we'll end this right here. I thank you for watching Gregg's Vintage Workshop.